Hello everyone. So let's see more few terminology regarding graph. Okay. So in graph, a path means it's a list of vertex P1, P2 to Pk. All right, where there exists an edge between two adjacent nodes. For example, if we have a path looks like this, okay, it means that we can say that for any adjacent two node there is going to be a edge. So there will be an edge from P1 to P2, P2 to P3, P3 to P4, or P4 to P5. So what it means that actually there is a path between P1 to Pk. Okay, and this path has this set of node. All right, so for example here you can see that we have a path from A, B, D, E, and F. Okay, so the path looks like this: A, B, D, A, B, D, E, F. Okay, that means we have an edge from A to B. Okay, from B to D, from D to E. All right, and E to F. So this is the path. Okay, so the path means actually a path from a, there is going to be a source and there is going to be a destination. We can say that there is a path from A to F. And what does this path look like? Okay, so there is not a direct path from A to F, but we can go from A to F by following this path. Okay, by following this set of connection. We can go from A to B, B to D, D to E, and E to F. That makes A, and that creates a path from A to F. All right. So a path is a list of vertex and we're going to represent them like that. So we can say that there is an existing edge from any two adjacent node. Okay. And we can, this path means this path has a source P1 and destination Pk. Okay. So another two path here we have C to D. You can see that we have a path from C to D, and another path we have A, B, B to D, D to E, E to G. All right. So a simple path means there is no repeated vertex. Okay. So by path means always we say that a simple path means there is no repeated vertex. Okay, it's not like that. Let's say I'm saying that I go from A to B, B to A, then A to B, then D, E, F. Okay, like if I say that like that, A, B, D, E, F. So I'm thinking like that I will go from A to B, then again I come back A, then again go from B, okay, then go D, E, F. So this can be also path, but a simple path definition means actually there is not going to be any repeated vertex. When we say that we have a path from A to F, means that we can go from A to F by following a path without any repeated vertex. Okay, so this is not a simple path. Okay, so this is not a simple path. And by path, we always mean actually a simple path. All right. So some other terminology we want to talk about, let's see, cycle. All right. So a graph can have cycle. All right. So if we have a subset of edges that form a path such that first and last node are the same. Okay. So that is known as a cycle. For example, here we have a path from A to A. Okay. Like we can go from A to B, B to D, and from D we can follow another path and we can reach to A. Okay, so here this is an example of a cycle. So cycle means simply, in an undirected graph, cycle means simply where the source node and the destination node is same. Okay, now AB is not a cycle. Obviously you can see that source and destination, they are not same. All right. Now, in a directed graph, the cycle means actually we have to follow a direction. And to define a cycle, we have to follow a direction to check whether there is a cycle or not. So in the last example, in the undirected graph, we saw that we have this cycle A, B, D, A. Okay, but if we assign direction like this, you can see that here we can go from B to A, but we don't have any other path. Okay, so here this is not actually a cycle. All right, so you can see that we can go from B to D, D to A. Then again, we don't have any path that we can go from A to B. Okay, so but here this is not a cycle. All right, but here if we change the direction, we actually did change the direction. Here this is a cycle. Okay, so in a directed graph, we can see that a cycle means it's a path. All right, P1 to Pk, where P1 and Pk is the same. All right, so in a directed graph, actually to define a path, we have to follow the directed edge, follow the direction of the edge. Okay, for example, in this directed graph, we have a path like A, B, D. All right, we have E, G. Okay, because you can go from A to B, D, E, and G, following the direction. Okay, but we don't have any path like this A, B, D, and C, because when we are here A, B, D, we can see that we don't have actually any path from D to C. Okay, so that's not a path. All right, not a path. Now here, if we have a path where P1 and Pk is same, we can say that it's a cycle. Here you can see that we have a path like from A to B, B to D, D to A. So that's a cycle. All right. A connected graph means every pair of vertex is connected by path. Okay. So if we, if we just select any pair of node, okay, from this graph, all right, we should be able to find a path between any graph, any pair of node. For example, let's pick A and F. Is there a path between A and F? If I look at that, I have actually path. I can go from A, D, E, F. That's a path. I have another path, A, B, D, E, F. Okay. Now pick any pair of node. There should be a connection by a path in this graph. For example, A to C, A to D, A to B, or any pair of node like B to F, there should be a connection. All right, so there should be a connection by a path. So if this is if this is the case, means every pair of vertex is connected by a path. This is known as a connected graph. All right. So this graph is connected. Just pick any any pair of node. All right, you will see that this pair of node has a path between one node to another node. All right. So here, this is an example where this is not a connected graph. Okay, if you pick A and F, okay, this is not actually connected graph, and also known as this is this is not a connected graph because here you can see that there is actually a break here. All right, so if you pick any pair of node here, like any pair of node from this set and this set, you will see that they are not connected. Okay, A and F, there is no path that you can reach from A to F or A to E or A to G. Okay, so this is an example where this graph is not a connected graph. So let's talk about different type of graphs. Okay, so different type of graph. One type of graph actually we're already familiar with, known as a tree. Okay, so think about tree. What is a tree? We say that a tree means a tree has a root. All right, so root can have root means is the node that doesn't have any parent. Okay, and each node can have some children. Okay, and leaf node means that do not have any children. Now, if you think about like a definition of graph, Graph means we have a set of node, all right, and set of edges. Edges represent the connection between two nodes. Okay, so obviously if you look at this tree right now, you can see that this is actually a graph. Okay, so here if you actually think B as a root, you can see that B doesn't have any parent, but B has three children, A, D, and C. A has one children, D has one children, C is a leaf node, no children, E has two other children. Okay, so you can see that this is a graph and also this is a tree. So what is a tree? Tree is actually a special kind of graph. Okay, so tree is a special kind of graph. We say that not every graphs are tree. Okay, not every graphs are tree. So what is a tree? Tree is a special kind of graph. We can say that every tree, okay, each tree is a graph, okay, but not each graph is a tree. So tree is a connected, unweighted graph without any cycle. Okay, so tree is a connected, undirected graph without any cycle. So it's very important that we have to remember it has to be an undirected graph and it cannot have any cycle. Okay, so now just let me draw an edge like this. Okay, so if I have an edge like this from A to D, you can see that I am having a cycle here. Okay, so here what I'm saying that B has three children, A, D, and C, and A has also children D. Okay, it doesn't actually make any sense in tree. All right, so in tree, A, D, C are supposed to be sibling. Okay, they have the same parent, but I cannot say that D has parent which is A. I mean, one node can have actually multiple parent, so that's not what tree is. Okay, so in tree, remember, it's very important, tree means we cannot have any cycle. Okay, it has to be a directed graph. I'm sorry, let me say that again. It has to be an undirected graph. Okay, undirected, okay, and no cycle. All right, it will be connected because for each pair of node we'll find a connection. Okay, for example, from F to E, there we see that there is no edge, but we'll have a connection. We can go from F to A to B, B to D, and D to E. All right, so another property of tree is that connected, undirected graph, no cycle, and connected. Okay, so as we are saying that every tree is also a graph, but not every graphs are tree. All right, so for tree we have to specify root. Is very important. We have to actually specify a root, and the relation between a two node is actually parent and children. If they are connected, if there is a age between them, the only relation is going to be parent and children. Okay, for example, here we can see that the root is C. Okay, if we specify the root is C, yeah, the tree is going to look like this. So C to B, C has only one children, B has two, okay, A has one, like this. All right. All right, so this is another, if we represent this as a tree, we can say that, let's see, A is the root, and you can visualize the graph as a tree. Okay. So another type of graph is known as complete graph. A complete graph means a graph where an edge exists between every pair of node. Okay, between every pair of node. Okay, so an edge exists between every pair of nodes. So it means actually each nodes are connected with each other. So for example, here in this graph, you can see that we have only 5 nodes. Okay, and every nodes are connected with each other. So A is connected with B, C, D, and F. F is connected with B, A, D, and C. Okay, like that. All right, So let's draw another complete graph between three pair of nodes, A, B, and C. Okay, between three nodes. Okay, so if we have a three node, let's see, A will be connected with B and C. Okay, B and C. C will be connected with A and B. B is connected with A and C. So this is an example of complete graph. So let's have four nodes. So A will be connected with B, C, D. B will be connected with A, C, and D. D will be connected with A, B, and C. So that is a complete graph. Okay, so a complete graph means there exists an edge between every pair of nodes. All right. So another type of graph is known as bipartite graph. A bipartite graph means in this bipartite graph, we can partition the total set of nodes into two sets, X and Y. Okay, so in a bipartite graph, we can partition every vertex into two sets, X and Y, such that all edges is going to connect a vertex where one node will belongs to one set and another node will belongs to another set. Okay, for example, you can see that in this graph, if we consider that this set of node in one set X, this set of node belongs to another set Y. Okay, so all the edges, you can see that one node will come from one set and another node will come from another set. There will not be any edges where both comes from the same set. Okay, if we have a edge like this, okay, if we have a edge like A to B where both A and B from the same set, that means that's not a bipartite graph. So in a bipartite graph, we say that every edge, okay, for every edge UV, U will belongs to set X and V will belongs to set Y. Okay, and X and Y, they are actually completely, totally disjoint set. Okay, so X and Y, they are completely, totally disjoint set. And in this graph, we can actually partition every vertex into these two set, X and Y. Okay. All right. So where we can actually use bipartite graph. Let's say we're making a matchmaking. Okay, matchmaking application. So in matchmaking application, let's say we are only dealing with, we're only having two set where we have in one set, we have list of women. Okay, and here we're having list of men. Okay, and in this matchmaking set, we are going to find a match from one woman to another man. All right. So in this particular application, or the only connection will come from one node from this set, from W set, from another node from M set. Okay. Like this. There will not be a connection from the node from the same set, from two nodes from the same set. All right. All right, so another application we can think about, let's say we're building a network, a relationship between course and instructor. Okay, now course means list of course and instructor means list of instructor. Okay, now in this particular application, we are going to have a network we are going to represent only the relationship between course to instructor. Okay, which instructor is teaching which courses, that's it. All right, so in that case, we can have an edge from only course to instructor. So we don't need any edge from course to course, okay, or instructor to instructor. All right, so like this. So I1 teaches C1, C2, I2 teach C3, like this. And C1 is also taught by instructor 3. So here you can see that this is also an example of bipartite graph. Okay.